Got another set of questions for the bonding and structure topic, and as always the link to the questions in the description of the video if you want to try them first. Okay, so make a start. So obviously each chlorine's got 7 valence electrons, so I've gone for crosses for the chlorine. One of them is shared with the carbon electron. Carbon's obviously in group 4, so we need 4 of a different type of electron, so I've gone for the shaded circles there. Obviously this is a double bond to the oxygen, so we need 2 pairs in the shared part. And I've gone for open circles for the oxygen, which needs 6 electrons. So moving on to the shape, it's obviously a trigonal planar shape. Why is that? Because we have 3 electron regions around that carbon. They're all bonding regions, and so we have equal repulsion. Moving on to the next question, so sodium sulfide's ionic, so we need 2 Na plus ions. I always go for crosses for the metal ion, so you can have 8 there, or you can have an empty outer shell. And the sulfide ion needs 6 of a different type of electron, and those 2 crosses the 2 electrons that have come from the 2 sodiums, 2- charge. And moving on to the last part of the question, so you'll notice I've added some information here that we'll need to bear in mind for the answers for the boxes. So sodium sulfide is ionic, we've already been told that. Sodium on its own has a metallic structure, it's a metal. Sulfur forms a covalent structure, and we need to be aware of the fact that it forms the S8 molecule. Okay, so type of structure, so giant or simple. So ionic substances all have giant lattice structures. All metals have a giant metallic structure, and something like S8 would be classed as a simple covalent structure. So moving on to the electrical conductivity. So in the solid state, sodium sulfide, which is ionic, can't conduct, so it's a poor conductor, and that's because the ions can't move, they're fixed, they're held in the lattice. However, in the liquid state, the ions can move, so it becomes a good electrical conductor. Moving on to sodium, which is a typical metal. So metals have delocalized electrons in their structure. So in the solid state, those delocalized electrons can move, and likewise in the liquid state. So sodium is obviously a good conductor in both physical states. Moving on to sulfur, so covalent substances don't have any mobile charge carriers, they don't have any free electrons, they're all used up in the bonds, and obviously they're not made from ions, so it's poor for both.